Hey gang, today we're going to be graphing linear and nonlinear functions. Up until this point, we've only graphed linear functions, and those are functions that are written in y equals mx plus b form, also known as slope-intercept form. When we graph those, we get a straight line, hence the term linear. So we're also going to be practicing graphing some nonlinear functions. So if you have something that's nonlinear, when you graph it, it's not going to be a straight line. Let's take a look at what that looks like. Here's our first example, and hopefully just by looking at the equation, you know right away that this is going to be a linear function. And it's going to be linear because it's in that y equals mx plus b form, or slope-intercept form. But instead of using the slope and the y-intercept today, we're going to fill out the table first and then graph it to prove that it's linear. So to use the table, we start by plugging in the x values to get out the y values. The x is the input, the y is the output. So we have negative 2 times negative 4 plus 3, which is 8 plus 3, or 11. Then we plug in the negative 2. So that's negative 2 times negative 2 plus 3, which is 4 plus 3, or 7. Then we plug in the 0. So that's negative 2 times 0 plus 3. So that's 0 plus 3, or 3, which will be our y-intercept. Then we plug in 2. That's negative 2 times 2 plus 3, or negative 4 plus 3, which is going to be negative 1. And then negative 2 times 4 plus 3, which is negative 8 plus 3, or negative 5. So now we're going to plot those points as if they're coordinates. Negative 4, 11 is left 4 and up 11, which is all the way at the top. Negative 2, 7 is left 2 and up 7. 0, 3, stay at the origin, go up 3. 2, negative 1 is right 2, down 1. And 4, negative 5 is right 4, down 5. Then take a straight edge or a ruler and draw your line through your points. So in this case, label it with the equation, y equals negative 2x plus 3. We know we have a linear function, not only because it's in slope-intercept form, but it's also a straight line when it's graphed. So we're going to say this is linear because it is in slope-intercept form. And a straight line when graphed. All right, so we already know linear functions. Let's take a look at what a nonlinear function might look like. All right. Now we have y equals 8 over x minus 2. We've never seen one like this, so chances are this is going to be nonlinear, but let's prove it. So we first start by plugging in that 1/2. If we do 8 divided by 1/2, which is the same as 0.5 minus 2, we get 8 divided by 1/2, which is 16 minus 2, which is 14. Then we can plug in 1. 8 over 1 minus 2 is 8 minus 2, which is 6. Then we can plug in the 2. 8 divided by 2 minus 2 is 4 minus 2, which is 2. Plug in the 4. 8 divided by 4 minus 2 is 2 minus 2, which is 0. And then 8 divided by 8 minus 2 is 1 minus 2, or negative 1. Okay, so now we can plot those coordinates. 1/2 is going to be between 0 and 1, so we're at 1/2 all the way up to 14. Then 1/6, right 1, up 6. Then 2, 2, right 2, up 2. Then 4, 0, right 4, stay at 0. Now, I can't plot that 8, negative 1 because I don't have the space there for my coordinate plane, but if I were, it would go down below the x-axis. So from here, I can draw my line. And I could do something like that. That would be enough. And that proves that this is nonlinear because the line is not straight. So we're going to write this is nonlinear because it is not in slope-intercept form and when graphed, it is not straight. Okay, so nonlinear here is definitely because that x is in the denominator, like we talked about earlier. We've never seen y equals mx plus b form with an x in the denominator. That doesn't allow for a slope, so therefore we know that it's not going to be straight. Let's take a look at another example. Okay, so 3y equals x squared minus 5. So although this kind of looks like it's in slope-intercept form, we've never seen an exponent before. So let's see what happens here. So now, again, I plug in that -4. I get -4 all squared minus 5. When you're squaring, you're multiplying the number by itself. So that's -4 times -4, which is 16 minus 5, or 11. Then we get -2 squared minus 5. -2 times -2 is 4 minus 5, or -1. 0 all squared minus 5 is 0 minus 5, or -5. 2 squared minus 5 is 4 minus 5 again, so we get -1 again. And then 4 squared minus 5 is 16 again, minus 5, so we get 11 again. So let's see what happens here. If we graph -4, 11, we go left 4 all the way up to the top to 11. -2, -1 is left 2, down 1. 0, -5 is like the y-intercept. We stay at the origin, down 5. 2, -1 is right 2, down 1. And 4, 11 is right 4 all the way up to the top for 11. So in this case, when you draw your line, you get a U shape. So that is definitely not straight and definitely not linear. Make sure you also always label the line. I don't think I did that in the last, so make sure you do. So again, we're going to write this is nonlinear because it is not in slope-intercept form. And its graph is not straight. So in this case, the thing that's making it not be in slope-intercept form is the exponent. Any equation with an exponent in it is going to be nonlinear. All right, so here you're going to be on your own for a little bit. You can pause the video and try 4 and 5 on your own or with a partner. Check in with me before moving on. Okay, now that we've done some tables, you might be seeing some reasons why a graph would be linear versus being nonlinear. So let's take a look at these two tables and see if we can figure out if it's linear or nonlinear. So in this first table, we go from 2 to 4, which is 2, 4 to 6, which is 2, 6 to 8, which is 2. We go from 10 to 16, which is 6, 16 to 22, also 6, 22 to 28, also 6. That 6 over 2 creates an equivalent slope throughout. So this is going to be linear because it's increasing at a constant rate. Okay, then over here, if we look at this one, looking at the x, it's increasing by 2, increasing by 2, and increasing by 2 again. Looking at the y, 3 to 15 is increasing by 12. 15 to 35 is increasing by 20. 35 to 63 would be, if it was 35 to 65, 30, but it's only going up by 28 because it's 2 less than that. So I have 12, I have 20, I have 28. 12 over 2, 20 over 2, and 28 over 2 are not the same. So it's not increasing at a constant rate. So this is nonlinear because it is not increasing at a constant rate. Okay, so it's important to be able to recognize that from the table. So you're going to try one last example like that. Again, make sure you check in with me when you're done so I can be sure that you've got it right, and then you can move on to today's exit ticket.